Hello and welcome. Thanks for coming to the talk. I'm told this is the absolute last one of Ignite, so I appreciate it. All right. Okay, let's make it good. It will be is the mic okay or too loud? It will be a very practical talk, hands-on. I'll show you a bunch of code samples. The talk is about using Microsoft Graph to perform high-scale operations on your Microsoft 365 data. Especially if you have an organization with thousands of people, tens of thousands, hundreds of thousands, you'll often run into performance problems using PowerShell. It just takes too long to do certain things. I see you over there. So a few words on Microsoft Graph. It's a web API, a REST API that allows you to access all your Microsoft 365 data, so Exchange, emails in Exchange, files in SharePoint, users and groups in Azure Active Directory, Teams, and many other things, audit logs, everything. It used to be that we had a lot of different APIs. You had to call Exchange APIs for some things and SharePoint for others. Microsoft Graph aggregates this all. It's a single authentication, single permission model, so it's easy to work with. Typically, we talk about two types of scenarios that you would use Microsoft Graph for. One is to build a user-facing application. You're a developer. You want to build an application that accesses emails, calendars, files. But the other class is you're an administrator and you want to manage your organization. So you want to run a bunch of processes on users, modify them, read them, create a report, anything. So today we're going to talk about that second class of scenarios for admins. And in there we have real-time scenarios where you want to access data as it is right now and you need to modify it. For those, we recommend use PowerShell or Microsoft Graph. And there's a list of different ones I'm sure you're familiar with. And there's a different class of scenarios where you're more interested in large-scale analysis of your data, but you don't really care about real-time that much. For that, we have solutions like Workplace Analytics, which give you a bunch of insights into emails and calendars. At this Ignite, we announced Microsoft Graph Data Connect, which allows you to, without writing any code, set up a sync process that takes your data out and puts it in Azure storage. We recommend you use this type of solution when you're interested in non-real-time analysis of your data. It does all the heavy lifting for you. But if you do have to work with your data in real time, for example, to modify it, you'd probably use PowerShell today. And if you have a lot of users, you probably wish it were faster. So we're going to show you how you can do that with Microsoft Graph. First, and I'm just going to scoot over here so I can do some pointing. This is what happens if you're getting all the users in your organization using PowerShell or Graph, the basic approach. You're asking for users. PowerShell calls out. It gets 1,000 users at a time in a single page, has a next link pointing to the next page, and it just does that all the time until it's done. So if you do it on a set of 100,000 users, you'll see there will be 100 calls, and it's going to take around 5.5 minutes to get all the data, my experience. So how can we improve that? We have to somehow break the collection of users into smaller or independent parts so we can put more load on the server, because the server can handle way more than this. We're just being very slow talking to it. So one approach is to try and break the collection up by using a query that will create independent streams of users. So what I did here, I found a property that actually is indexed and results in very efficient queries in Azure Active Directory, so the user principal name. And I'm asking the server to give me just users whose name starts with an A, then users between A and B, and so on. So as you can tell, there are like 27 different streams that I can work with independently. That's key to this. And then I use 16 concurrent network connections to Graph to launch all these requests simultaneously from my client. And within those, I just do the old-fashioned thing of following the next links. But I'm keeping the server and my application quite busy instead of just waiting for network operations to finish. So as you can see, the impact is pretty significant. I'm getting the same amount of data in 18 seconds, which is 18 times faster. Now, how you do this type of partitioning highly depends on the particular resource. So on users, you could do this. On groups, you could do a similar approach. In Exchange emails, there is no equivalent that I could find. So it's a bit of an involved process where you have to like figure out the right kind of partitioning scheme. But if you do have a high scale and you're blocked by the slow performance, it might be worth your time to investigate that, to get something that runs so much faster. Now let's look at the update operations. So here I'm assigning licenses to users, but that could be any update operation. The typical approach, again, PowerShell, I have a list of users, maybe the users I downloaded before, analyzed them and figured out I need to update 1,000 of them. I would be doing this one user at a time. Extremely slow. These are tiny requests, but doing them one user at a time results in 1,000 calls and 4 minutes to process 1,000 users. It's probably you're familiar with that. Again, what can we do about that? We can use still parallelization that we discussed before, but we can use this feature in Graph called batching. If you look at these boxes here, the $batch operator allows you to actually insert up to 20 independent requests into a single request. So by doing one network operation, you're essentially asking the server to perform 20 independent operations. They can be across different resources. They don't have to be related to the same resource. Here they are. If I combine this with the parallelization scheme where I have 16 independent streams, you can see that I'm actually sending up to, might be hard to see, 320 requests to update a user at the same time. I'm keeping the server pretty busy with all these write operations, but that's the best I can do. And that results in 20 time improvement over what we were doing before. In 12 seconds, I'm getting all that work done with only 50 network calls going out instead of 1,000. Now, it's not that rosy because the servers, the cloud services have to protect themselves from applications that put too much load on the system. So whenever you're doing something like that, you should expect to get throttled by the system, and you should handle that. And there are easy patterns with Microsoft Graph to catch the 429 response code, and there's always a retry after value included in the response, which tells you how many seconds you have to wait before you try again. So you can implement a simple pattern where you put as much load as you want, you get throttled, you wait, you put load again. Typically, how throttling behaves varies from the actual service behind Graph. Typically, the rates are much higher. Your limit is much higher for read operations. In that first scenario I show you, I almost never get throttled. For write operations, they're much lower in Azure Active Directory for sure. A quick note on how this works with batching. It's a little bit more involved. At the bottom, you see a response from a batch operation, which is successful, the yellow line on top. However, it includes individual requests that failed. So you have to kind of parse the whole response, pick out the ones that failed, retry them. In this case, one of my requests in the batch got throttled, the other one didn't. So my code that I'll show you later would catch the first one and put it into a retry queue and then try it again. Here's a short study that I did of what throttling means to your overall performance. It turns out that throttling, at least in Azure Active Directory, can significantly impact the overall performance of your app. So here what I did was I added 100 users to 100 groups each. So 10,000 write operations. That could be a scenario in your organization where you're creating new classrooms or new hierarchies. I originally launched it at full speed with 16 concurrent streams. It took 9 minutes, but it turned out that my actual requests completed in 1.5 minutes. The 7.5 minutes extra was just my app waiting for the throttling intervals. Because I generated around 6,500 requests per minute, and the server got upset at me and said, well, can't be doing this that much. So I ran into 3 periods of throttling, which added up to 7.5 minutes. So then I started reducing the parallelism as a way to control the request rate. And I found out that actually at 2 parallel streams, or even at 1, I'm getting the best overall performance here because I'm limiting throttling even though I'm very slow. So this is not great. Today, Microsoft Graph doesn't give you much information about the fact that you're going to be throttled. It doesn't let you discover your kind of like budget for operations, so you could automatically adjust. So it means that you have to kind of, if you're building a production scenario, you would have to experiment and fine-tune it by hand, which is not ideal. We have some plans to fix that in the future. But today, the approach is you hit it with a lot of requests, and then you find out how upset it gets at you, and then you give it a minute to take a break. Let me do the demo real quick. So just to show you that all this can be implemented in a pretty neat way. So I have this sample code up on GitHub that I will give you a link for. And my goal here was to implement all these things in the background in such a way that I could give this to say an administrator or someone who's familiar with C#, but not a huge expert developer. And I could let them build scenarios quite easily while behind the scenes the code executes all that fancy parallelization stuff. So if you look at this function here, it's called get all groups with members, and it downloads all the groups in your organization with all the members in them. And the way it's implemented, if you ignore us, you can see most of the text is my comments. So it's not a lot of code. What it does here, we create a little builder that I created. And in here, we split the collection into all these independent requests. So we're filtering by the name of the group, like I just was on the users. And we use a standard SDK syntax to say, hey, could you give me all the groups? But what's cool about this solution is that the code, the actual request, doesn't go out here. The SDK thinks it's sending a request, but I actually intercept it and I give it to my manager that will batch it and do all those fancy things. But the administrator here is writing their code not knowing about that. They don't have to know about that. So this lets me download all the groups, the group objects. And as I'm getting them in the background, they're not necessarily all downloaded immediately. I don't have to wait for them. As I'm getting them, I'm creating a request per group to get all the members. So again, groups are coming down, and I'm asking for members. And all this is happening at the same time. The cool thing about that is that this collection here, groups with members, is being populated in the background. So I can start working on it. I could, for example, hand it off to my code that will do something with the groups. I don't know, start building a report or correlate it with other data without it having to wait for the whole thing to finish. So my app can stay busy doing other things as we're doing all this talking to Graph and waiting for throttling and all those things. I can be executing my client-side code independently of that. So let me run this for you just to help you visualize. Let's see if it's not a pretty demo because it will involve a console app and Fiddler. But it should illustrate what I'm trying to say here. So here it is running. So you can see every time you see a new line here, it's like the whole group with its members has been downloaded. And here's what it looks like in Fiddler. So these are all the requests to get members. They're actually inside of a batch, and they're coming down here. What you'll notice is how much I'm sending in. See how many lines are created here? I'm really being pretty intense here, sending network requests to the server. I have 16 connections open. And eventually, Now I hit a large group, so it's taking a while to get that final group fully downloaded. But my code could be working with all the other groups already if I needed it to. And here, here we have all the groups. No, I cannot really zoom, sorry. And you can see that if I grab a group, it actually has all the members in it. This one has 13,000 of them. Again, the key here was to design it in such a way that a person who's not super advanced in more sophisticated development techniques could use this kind of as a script. Still going to be more complicated than using PowerShell, but the idea is you could at least isolate most of the complexity. So you can have a look at this GitHub project that I created with this. There's a bunch of other scenarios, getting all users, managing licenses, getting mailbox content, creating a report of registered devices, and there are some more advanced things with Delta Query that I'll talk about in a second. And if you have any comments, you can leave them there on GitHub. I'll be monitoring that, and we can collaborate on it a little bit, see how far it goes. A few other interesting things you may want to look into if your organization is large. We have a Delta Query functionality in Microsoft Graph. It allows you to track incremental changes to resources. So what I showed you, as cool as it was, you don't really want to run this script all the time, downloading all your users over and over again, because that's wasteful. Delta Query allows you to download the user state, let's say, once, and then just you get a token and you can call back and it'll give you incremental changes over time. So every 5 minutes or every day, whatever you prefer, you call and it tells you just about the users that changed. So a scenario would be creating a report and then keeping it up to date by feeding it the results from Delta Query. Webhooks is another technology we have, also for change tracking. It's the push model. Think of it like the push equivalent for Delta Query. So you publish a web endpoint, and we will call you every time an object changes. So you don't have to call us. We're making investments into that to being better and supporting more resources. So there are some links in the deck that you can follow to read more about it. To summarize it, the basic approach with PowerShell is absolutely perfect. We're not encouraging you to go and rewrite all your scripts. It's perfect if the size of your org is not too big, or if you don't have these large operations. So if you're in like thousands of users range, you probably don't need to do what I showed you. But if your organization has 100,000 users or 4 million users, like some of our customers, you're probably struggling at this point, and it might be worth evaluating that more complex option. That's it. It wasn't it, sorry. A few useful resources just to get your attention. JSON batching and graph, how to handle throttling, my code that I showed you, and the Data Connect feature for working with your data through Azure storage. Please evaluate the session, and I am happy to answer any questions. Uh-huh. Yeah. You should ask us to, the question was, they work with a large organization that has 150,000 mailboxes, and they use a PowerShell commandlet, correct, to get the content of mailboxes, and it takes a very long time. However, the Graph API, the equivalent Graph API, is missing some of the functionality. Yeah, you should come and talk to us or file a user voice feedback through user voice. Ask about that. I could relay your feedback too. Right. Yes, correct. Can I ask you what's missing? Oh, I see. Yeah, I see. Okay, we can follow up and ask the Exchange experts on what the plan for that is. Uh-huh. There is a scenario in my sample code that does exactly this, downloads all the mailboxes for all users, but it might be missing that particular property that you care about. Mm-hmm. Correct. Yeah, thanks. Any other questions? So all that you saw is using the SDK. One of my goals was to, it's not a prerequisite for any of this, but I wanted to keep the request handling simple. So I actually kind of hacked into the SDK so you can still use the same syntax. As you saw, I was like executing the requests, but not really. That's the hacking part. You could totally do the same and handle it, create your requests. It's a common, I think, misunderstanding. I had that question a lot. People thinking what makes their solution slow, and they think it's the network or they think it's their client code. Most of the time, it's just input, output over the network. And yeah, the SDK, does a lot of serialization, deserialization, but it doesn't really matter when you compare it to the megabytes of data that need to be sent over a network. So especially if you're doing that in the background, your SDK code's running while it's still waiting for more stuff. So it's like free time, essentially. Uh-huh. I am not aware of one. That's why I came up with this idea for this talk. We have a, good point, thanks. We have a Microsoft Graph community call that you can look up online. How often do we do it? Once a month. And we have people calling in, customers, asking all sorts of questions, so we could bring this to the table. I thought I would bring this to Ignite to get you guys interested, because working in the enterprise space, I hear this feedback all the time. People, serious customers, large tenants, getting frustrated, license management. We have some new features for that, but it used to be horrible. So let's get it going. Let's get it started on GitHub and the community call. Could be one way for you to say, hey, where's this property? I have this scenario, and you guys make me call PowerShell. I'd rather call Graph. You'd get them interested because they will be jealous of PowerShell. And then you'll say, but you're missing a property. And then people really see it, see that feedback, they react to it. Ayuba might look it up, yeah. All right, we're a bit over time, but I'm going to stay here for a few more minutes.